whatever, individually. I want you just to like on your sheet somewhere, not huge, because we're going to use the whole sheet, okay? I just want you guys to come up or see if you can figure out with this. I have an input and an output, and your job is to figure out what do I need to do, my change rule, in order to get from my input to my output, okay? And it has to be one rule that works for all of the inputs, okay? That's the name of the game, okay? And so on your slides, if you guys could, just write down like what you think your guess is or like some of your work, okay? As I flip through here. I might have gone too far. Okay, so just use the pen tool and put like, there you go. Hey, you guys are using stickies. You guys are better than I am. I don't know how to do that. Okay, so you guys can put on your slide, just write down like what you think the pattern is, or like the rule. Okay, and I'll flip through, or I'll pull this up and I can see. Okay, that's good, Bailey. Good, Lida. Okay, so you guys are just looking for a relationship between these here, right? And here. Like, how do I get from this side to the other? It has to be something in the middle. And what is that something in the middle? That's what you're trying to figure out. Oh, there you go. Gave you the answer. If you were paying attention. Okay. You guys will have to show me how to do these stickies. We haven't seen anybody's work. You guys could probably scroll through there too, right, to see everybody else's work. But you're looking for the thing that works for all of these. Well, your question should be like, how do I get from 4 to 12? Well, that seems like I'm going to have to multiply that by 3. Okay. And then for it to actually be a rule, you guys need to say, okay, it needs to work for all of these the whole way down. Okay. And so then you check, okay, does times 3, if I multiply 2 times 3, does it give me 6? Well, yes, it does. Okay, 4 times 3 is 12. You check it again here. 7 times 3, well, that's 21. Okay, we're good. Chances are if you get 3 of them, that's a good sign that you're on the right track, right? I would say if it's the same row for 3 of them, that's a good chance that it's right, okay? And then you check the last one just for ease of mind. 3 times 3, that gives you 9. Okay, so your rule here is we're going to take the input and multiply by 3. Okay? Now, what if I scroll down here? Can you guys together on your Jamboards figure out what the rule or pattern might be for this one? Okay, and I'll give you a couple minutes here. This one's a little bit harder, okay? Good, Liliana. That's good. Okay, you guys are looking, you're just trying things, right? You're trying to figure out what's going to work. Esme, that's good. Okay. So, you guys are looking at this and you're going, okay, well, 4 doesn't go into 22. That's a problem, right? There's no number that you can multiply, unless it was a decimal. But again, we're trying to stay away from that, right? Good, Ariel. Good. Okay. We're trying to stay away from the decimal stuff, right? Because chances are that decimal's not going to work for all of them, right? So if we were to go, I don't know, how do I get, you ask yourself, how do I get from 4 to 22, right? Well, I don't know, I think the closest you can get would be like 5, right? So you're like, okay, well, that's a start, but 4 times 5 is 20, right? That's not all the way to 22 yet. So what about from here to here? We're just going to try and develop a rule, right? By looking at this, well, we're going to say times 5. But again, 5 times 2, that's equal to 10, right? You're like, okay, well, that's not 12. Yeah, okay, well, we'll just keep running with it and see. It looks like it's close, right? 5 times 7, well, that's 35. Also pretty close, right? And then you're thinking, okay, well, 3 times 5, that's 15. There's another little piece here, right? You can see the commonality here is that as we go down the page, we're seeing this times 5 times 5 times 5, right? Then we're like, okay, well, how do I get from, like, is there a consistency between going from the multiplication by 5 and then the next number? Well, it looks like after you multiply by 5, we can add 2 the whole way down the page, right? And all of a sudden we get all these outputs. So nobody said that you had to just multiply by a number and that was it, right? We can do some other things, right? Where we're saying, okay, I'm going to take my input, this rule here, we're going to take the input, we're going to multiply by 5, and then I'm going to add 2, right? And that should work for all of them, right? And you're going to say, okay, that's the output. Output is equal to input times 5 plus 2. That's how you get from one side to the other. Okay. Sorry, you guys can't really see this either, right? Okay. So the question then becomes, how could I represent that if we were to build it with tiles, right? Well, if this was like a visual pattern, we could say, we could change this to like stage number. I don't know, maybe you guys haven't done visual patterns. We're going to do that today, right? We could change this to like the stage number and then how many of something there are, right? And then we would just do the same thing. We'd say, okay, well, in stage 4, we'd apply our rule. We'd take our input, multiply it by 5 plus 20 plus 2 should equal 22. So I should have 22 triangles or 22 circles in input or stage 4. Okay. Same thing. So if stage 2 will have 12 somethings, and stage 7 will have 37 somethings, and so on and so forth. You're applying your rule over and over again. Okay. So if I go down here, do you guys think you could figure out by looking at this visual pattern? Again, here's what we got. We got our stage number. Okay. Do you guys think you could come up with what that stage actually, the rule to get from 1 to 2 to 3? Okay, can you do that on your Jamboards? Okay, what if you guys, like, if you're looking at that, it looks like there's this like +2, +2. There's always this 2 there, right? We call this the constant, right? Because it's constantly there. Okay, and then we're asking ourselves, okay, I had these inputs. Okay, and your question has to be, well, how do I get the output? Well, the output, remember we said, was the number of tiles, right? The number of something, right? And so we're looking at the fact that, like, we need to take our input, multiply it by something, and then add the other something else, right? Well, the add to something else is always this constant. So we know we're always going to add the 2. And then you ask yourself, okay, well, how do I get the red tiles, right? Right? You're like, okay, well, in stage 1, there's 5. In stage 2, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In stage 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So we go from 5 to 10 to 15. It seems like if I take my stage number and multiply it by 5 and then add the 2, I get the total number of tiles that are sitting there in this question, right? So for instance, 1 times 5 plus 2 is going to be 5 plus 2, 7. There is 7 tiles there. You guys can't see that, eh? Okay. It should work for the next one as well, right? We're going to take our stage number 2. We're going to multiply by 5. That gives us 10. And then we add the other 2. Well, now there's 12 tiles there, right? In total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and so on and so forth. This looks like the rule, right? The rule you just came up with above. So we're going to take our stage number or input. We're going to multiply by 5 and then add 2. That's going to equal the number of tiles. Okay, if we turn our attention to the next one, it looks a little bit different. Okay, it looks different because, well, 1, 2, 3, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. There's always this like +5. There's always this +5, +5, right? It's a constant. But then you got to ask yourself, okay, well, how is the red changing? The red is changing. Okay, well, there's 2 here, and then it goes to 4, and then it goes to 1, 2, 3, 4, 5, 6. So it looks like it's like we're adding 2 red tiles every time. Okay, from stage 1 to stage 2 to stage 3, right? Well, another way to think about that, like this +2, +2, another way to think about that is that we take our input, our stage number, and if we multiplied it by 2, right? So we take 1 times 2, that's equal to the 2 reds. And then additionally, we write our +5. Okay. And then we do the next one. Stage 2 times 2, there's 4 red tiles, plus the original 5, or the constant 5. Right? And then we do it again. 3 times the 2 should be 6, plus the original 5. Okay, and what ends up happening is we get this like recurring pattern, or this rule, right? Where we take our stage number and we multiply it by 2, then we add the original 5. That's there every time. Right? That equals the number of tiles again. You guys can see the reason why I picked this slide in particular. When I come down to look at the rules, you guys can see the number of tiles equals position number times 5 plus 2. That's what we wrote at the top. That looks very different. The pattern on the left looks very different from the pattern on the right. Correct? You can see how, just by looking at this, it looks like the one on the left is going to grow faster. It's going to grow faster because of this multiplication by 5. Okay? On the right, it doesn't look like it's just growing as fast because we're only multiplying by 2. Okay, the number of tiles isn't as many on the right, right? You can see how all that's changed between the left and right equations is where those numbers are located, the times 2 times 5, right? And then the plus 2 plus 5. That's the only thing that's changed between those two equations or rules, yet they yield significantly different patterns or numbers of tiles, right? And I suppose the point that this is trying to make is that you guys have to be very careful with where you put what, because it's going to give you two different answers. Okay? So, can we take, I don't know, 2 minutes? Okay? We'll try to figure this out. What the rule could be for this particular pattern. You guys can do it on your board, okay? Your Jamboard. Okay, I'm just going to flip through some of the slides here, okay? See what everybody's doing. Okay, Liliana looks good. Lida, that looks pretty good too. Just watch what you're putting in the stage. Oh, I see. It's the. Never mind. You're okay. It's the sticky. That's funny. Guys, everybody just look at the way Lida's organized her like Jamboard as we go through here, right? Every question that we've done, we have this nice number, and then I can see kind of what you guys are thinking as we go through here, right? Nice and organized for each question. Hey, okay. Esme, I like some of the language you got going on in there. Okay, Esme is saying, okay, we're going to start with 4, and then we're adding 2 each time. That's good. Okay. What I might end up having to show you guys, we just kind of like, I had some other stuff planned for some of you this afternoon. I might just leave it. We're gonna work through this question just before we leave. Okay, but when we come back this afternoon, we're gonna try a few different questions, just particularly around like the visual patterning stuff, and then I'll show you how to graph them too. Okay, that's where we're headed. So Esme said something interesting. Okay, we start with 4, right? It looks like, and then add 2 each time. So Esme identified that we were just gonna add 2 each time, right? We're seeing that, okay, we're going from 2 to 4 to 6, right? Now the use of the word start with indicates that we're talking about these 4 tiles on the outside, right? Right? And so when we start with something, or if we start a race or something, we're always going to start at time 0, right? Or whatever, right? We're starting at 0 because that's our starting point. So our question really is like, what's the starting value? Right? Well, we know that these tiles are increasing by 2 each time, right? So plus 2, plus 2, right? And then you always have this like constant 4 tiles floating on the outside, right? As you go through this pattern. Now, to figure out what our starting value might be, we would say, okay, well, if I'm going to add 2 to go to the right, then I could also subtract 2 to go to the left. That's also okay, right? And by the left, I mean like, how do we go from 1 over to 0, right? To the right, we're going 1, 2, 3. To the left, to get to our starting point, we could subtract 2 tiles. Well, the 2 tiles that we're going to subtract are going to be these ones in the middle. And we can say, okay, here's what stage 0 is going to look like. And I'm going to, oops. It's not easy to do. Okay, that's what stage 0 would look like, and there'd be no tiles in the middle. Okay, so this is what Esme meant by we're starting with 4. Okay, some of you already probably recognize as well, like because there's always 4, always 4, always 4, this is kind of like your constant, right? There's constantly 4 there. It's 4, so it's always gonna be there, it's always floating on the end. Okay, how is the pattern growing or changing? Could be decreasing too. We haven't done any of those yet, but in this particular question, we're adding 2 each time, right? Well, another way to say adding 2 each time is we take whatever the stage number is and multiply by 2, right? So we could say stage number, or let me reword this. It's 2 times the stage number plus 4. That's going to equal, sorry, you guys can't see that. That's going to equal the number of tiles.
Wait, the fact that I'm doing this on a piece of paper is okay, right?
Oh yeah, absolutely. Yeah.
Okay.
The Jamboard, like if Jamboards isn't your thing, it's not your thing, right? It just allows me to see what everybody's doing.
Just I can't write with my mouse. And
yeah, it's a pain. It's a pain. I agree. Yeah. That's why I have like the iPad and stuff, because it'd just be a disaster if I didn't have this.
Oh, I should get a little pencil or something.
Yeah, okay. That's what I've got going. Does anybody have any questions of this? We're gonna pick this up after. I didn't get through everything that I wanted to this morning. I'll stop the recording there if it stops.